Hi there. Find a vector equation for a line passing through the given point and the given direction vector. The first is a point with position vector 3i and direction vector 2i add 4j. Now we know our vector equation is defined as lambda times the direction vector. A is the position vector and D is the direction vector. They already told us how our direction vector is, so immediately we can write that it's lambda times 2i add 4j, and our position vector is simply 3i. So our vector equation is 3i add lambda into 2i add 4j. Let me just make sure this is on the screen properly. Well, our second problem is we need to find the vector equation again for a point with position vector I minus j and a direction vector of 5i. And we can immediately write, we know our position vector, which is I minus j, and our direction vector is multiplied by lambda, which is just 5i. So number 3, a point with position vector 5j and direction vector I minus 5j will give us a vector equation of 5j added to lambda times I minus 5j. Right, our fourth problem, we have a given position vector as the origin, and the direction vector is three-dimensional, which is 3i add 4j and 2k. Now that gives us our vector equation is equal to, well, we have 0 for our position vector, and we have our direction vector is 3i and 4j and 2k, which we can write simply as lambda into 3i 4j add 2k. So it's not the 0 vector, it's 0. Anything added to 0 is that whatever is added to 0 is what it is. And lastly, our problem is a point with position vector minus 4i minus j add k parallel to a line with vector equation r equal to 2i add 3j add lambda in I add j minus k. Now a line parallel to the vector equation will be simply, well, we're given the position vector here for I j add k, and if it's parallel to a line with a vector equation, then it's parallel to this direction vector, and so we use the same direction vector. If you look at my previous videos, you'll see a definition of the direction vector, which is scaled by lambda to determine different points on a given line. Thanks for watching. I'm Alistair.